Okay, today. So yesterday when we did equations, all of our problems were addition problems or subtraction problems, correct?
Yeah.
And in every single problem we were solving the equation. And what was I having to do to that variable to solve the equation? What did I have to do to the variable? We wrote it down in our notes. Charlie? You have to isolate it. So right here where it says to solve an equation, we are going to isolate the variable. Now I want you to think back to your work yesterday. How did I know how to work the problem? What did I have to do? For example, if it was an addition problem, what did I do to work it out? Nathan?
Subtract.
I did subtraction. And if it was a subtraction problem, what did I do to work it out? I added. What are those called? Adding and subtracting. They are opposites of each other. Do y'all agree?
Yeah.
So, to solve an equation, we're going to isolate the variable by doing the opposite operation. Alright? So we're going to isolate the variable by doing the opposite operation. Which, for example, yesterday if it was adding, we did the opposite of subtracting. If it was subtracting, we did the opposite of adding. So when I'm talking about a division equation, I'm going to do the opposite of dividing, which is multiplying. Alright? Now this is where things get a little different than how you've done math in the past. So I want you to think back to earlier in the year. I told you that eventually you would write multiplication without writing the multiplication symbol, which we've seen, right? We put numbers next to each other in parentheses. We know that means to multiply. I also told you eventually you would not be using the division symbol anymore. And if you look at these two problems, I know that they're division problems, but how? Because there's not a division symbol. So how do I know that those are division problems? Parker?
The fraction bar.
They have a fraction bar. And that fraction bar also means division. So just like we don't write a multiplication sign anymore, now you're not going to write that division ... symbol. You're going to use a fraction bar. Okay?
Well, how would you know if it's a fraction now?
Okay, so P over 8, can I have a letter in a fraction that's supposed to be a number? No, a letter can't be in a fraction. A fraction still has to be a number. So does that make sense? So I know that this is going to be division because a fraction just doesn't make sense with a letter in it. Okay? Okay.
What if there's no letters, it's just numbers?
Then look at the fraction and decide. Is it simplified? If it's simplified, it's staying like that. If it's not simplified, simplify it. If it'll become a whole number, cool. It was a division problem. If it won't become a whole number, then you just leave it like a fraction. Does that make sense? Okay. And we'll see a couple of examples. Let's work some of these, see what's going on. That division bar can be either one. It can be a division bar or it can be a fraction bar. You have to look at the numbers to decide which one is best. Okay? But for right now, we're just talking about solving these equations. We'll talk more about how to write your answer in a little bit. Are we okay with the fact that this means division because of that letter? Right now, this cannot. There's no way it can be a fraction because you cannot have a letter in a fraction. All right? So this means division. When you're dividing, what do you notice? Your number is always located where? On the bottom. Your letter is going to be on top. Your number is going to be on the bottom. Guys, whenever you're dividing, it's really important we know the number is on the bottom. Now, guys, we've already said the opposite of dividing is multiplying. If dividing goes on the bottom and we're wanting to do the opposite, where do you think multiplying is going to need to go?
No.
On the top. So I'm going to show you what that would look like on number 1, and then we're going to do number 2 together. So for number 1, I'm going to draw my line still. And on P's side of the equation, I need to get rid of the 8. The opposite of dividing on the bottom is going to be to multiply on the top. And you'll notice to write my multiplication, I'm just putting the 8 in parentheses now. This is something we need to get more and more used to seeing. If I do it on one side, I've got to do it to the other side. So I'm going to put an 8 in parentheses next to the 10. Because there is no top and bottom there, so I'm just going to write it next to it. All right? An 8 on the top and an 8 on the bottom. Those are opposites, so what's going to happen? They're going to get crossed out. They're going to go away. Are those becoming 0, an 8 on top and 8 on bottom? Is that becoming 0? What is an 8 on top and an 8 on the bottom, Lauren? A whole number. It's a 1, which 1p is just p, which is why those are going away. So this is really becoming 1 here. We can just mark them out and make them go away because they're opposites. All right, and then over here it says 10 times 8, which is 80. Ta-da, you just did a division equation. Okay. All right, we need to check it just like we were checking them yesterday. We're still going to check them. All right, I'm going to go back over here and highlight our original problem. So my original problem said P divided by 8. When I do division, when I work it out to check it, I'm going to use that old-fashioned division symbol. P divided by 8. What number goes at the door? How do I know what to put at the door? Nathan? The 8, the denominator. So the denominator goes at the door. So I'm going to put 8 at the door, which means P would go in the house, but what did we just find out P was? 80. Okay. So let's divide this out and see what we get. Can 8 go into 8? How many times? 1. And 1 times 8 is? 8. When I subtract, I get? 0. So we're done? No, remember there's still this other number to bring down. How many times can 8 go into that 0? 0 times. So that gives me 10. Is that what I had originally? So did I get the right answer? Yes. All right. Questions about that? All right. So let's look at the next one. I'm going to go ahead and draw my line. All right. So this time it's still a division problem because it has that fraction bar. What do I need to do to both sides here? Raise your hand if you can tell me. What am I going to do to both sides on this problem? Parker? Multiply them by 3. And where do I have to put that multiplication? On the top. So I'm going to put times 3 on the top. Guys, if I put 3 next to 3, that's going to give me a 9. Do I want a bigger number there? No, I want the 3 on top to go away with the 3 on the bottom. If I do it to one side, do it to the other. Okay. So my 3 on top and 3 on bottom go away, leaving me with x equals, what's 15 times 3 give me? 45. So I get x equals 45. If you need to work that out to the side, you can. Okay, absolutely. All right, I still need to check it. So remember my original problem said x divided by 3. So let's check that using my division from the problem. What's going to go at the door here? The 3 in the denominator. And in the house we'll have 45. All right, can 3 go into 4? How many times? 1. 1 times 3 is? 3. When I subtract, I get? Let's bring down the 5. 3 will go into 15? 5 times. 5 times 3 is? When I subtract, I get? So I got 15 here. Is that what we originally had? Questions on division problems? Good. All right, let's look at multiplication. So again, we're going to fill that in again. Dividing on the blank is the opposite of multiplying on the blank. Where do you do your multiplication? On the top. So where do we need to make sure we do our division? On the bottom. Excellent. So for number 1, let's draw our line. All right, now guys, what's my new way of writing division? With the fraction bar. So here, How do I know that this is a multiplication problem? How do we know that? Peyton?
The variables represent the numbers.
Yeah, they're right next to each other. So I know that's multiplication. So the opposite would be to divide. So I'm going to draw my division line. What number am I dividing by? Nathan? Why? Lauren, why would I divide by 4?
Because you're on this side you divide right. On this side 4 is like the right side the variable.
4 is next to the letter. You have to divide by what is next to the letter. Just like up here, we have to multiply by what is under the letter. So this has to be a 4, and I have to use the same number on both sides. 4 divided by 4 gives me S equals 84 divided by 4. Charlie? 21. Okay, so I'm going to pause here. Are there any questions so far about this? Okay, so now I need to check it. All right, remember my problem says 4 times S. Do y'all agree? 4 times S. So instead of writing 4 times S, I'm going to write 4 times 21. So 4 times 21. Okay, 4 times 1 is? 4. And 4 times 2 is? 8. Is that what I had originally? Yes. Okay. Number 2. What type of problem is number 2? Multiplication. Cade, how do I know it's multiplication?
Because the number's right by the variable.
The number's right by the variable. And by the way, this is a 5. This is a 5 here, okay? So the number's right by the variable, so it's multiplication. What's the opposite of multiplying? Dividing. So let's go ahead and draw our division bar. What number am I dividing by? What number am I going to divide by here? Noah?
35.
35. Why?
Because it's next to the letter.
It's next to the letter. It looks really weird. In fact, I tricked some people last period. All right? Didn't get it past y'all. A is next to 35, so that's what we have to divide by, okay? And Kate and Kai, I think this is kind of what y'all were talking about, all right? This, as a division problem, would say 5 divided by 35. Can 35 actually go into 5, though? No. So instead of treating this like a division problem, since I can't divide it easily, I'm going to think of it like a fraction. Okay? It can be either one. Dividing just really doesn't make this an easy problem. Okay? So if I think of this like a fraction, is it a good fraction? Yeah, it's a good fraction. There is one thing that you can do to it, though. What could I do to it? Thank you, Peyton, for raising your hand. We can simplify this fraction. Okay? So what number can go into 5 and into 35? Charlie? 5. 5 divided by 5 and 35 divided by 5. 5 divided by 5 is?
1.
35 divided by 5 is?
7.
Equals, what's going to happen to my 35 and 35? Yeah, it's going to become just an A. Okay? So, visually now, do we understand what we're saying about if it's division, it's going to be pretty obvious. If it's a fraction, it's going to be pretty obvious. Okay? Here, we didn't even question if that was division because it was easy to divide it. Here, we can't divide it, so we just have to let it be a fraction. All right. Let's check it because we did get a fraction here, so we probably need to know how to check it. My problem said 35 times A, correct? Now remember, this is a fraction, so I'm going to write them next to each other. So I have 35 times A. What is A? 1/7. You guys, right now, can I multiply this?
No.
What could I do to make it so that I can multiply? What can I do? Lizzie?
Make 35 into a fraction.
Make 35 a fraction by doing what?
35 over 1.
Put a 1 underneath. Now can we multiply it? Yes. On the top it says 35 times 1, which is?
35.
35. On the bottom it says 1 times 7, which is?
7.
35 over 7. Can I simplify that?
No.
Yes. In fact, guys, could I read this like a division problem? 35 divided by 7 is?
5.
5. Is that what I originally had? Yeah. Or you could divide the top and bottom by 7. You get 5 over 1, which is still 5. All right. The last thing. Fractions are kind of funky because if I have a fraction next to a letter, that's going to be multiplication, right? So if we have a fraction next to a letter, let's talk about a fraction multiplication equation. Do y'all see how here I have a fraction next to the letter? And it's multiplication. Here I have a fraction next to the letter, and it is multiplication. All right? So let's think about this. It says the opposite of multiplying by a fraction is still multiplying, but what can I do to the fraction to make it the opposite? You flip it. Does anyone remember what the special word is called when you flip a fraction? What is that called? Okay?
The reciprocal.
The reciprocal. So we know the opposite of multiplying is dividing, but the problem is, guys, when you divide by a fraction, remember you keep, you change, and you flip. You change division to multiplying. So the opposite of multiplying by a fraction is actually multiplying by the reciprocal. Okay? So, again, let's draw our line. Right now I have 5, 6 times k. The opposite of multiplying by 5, 6 is going to be to multiply by what? 6 over 5. Because remember, the reciprocal just means to flip it. And you might want to write that in, that the reciprocal means to flip it. Are there any questions on where I got 6 over 5 from? Yeah, whatever's next to the letter, I just flip it. And if I do it on one side, I have to
Do it on the other.
do it on the other. So I'm going to write 6 over 5 here as well, using that same number. Okay. So, guys, what did we see happens to a 6 on the top and a 6 on the bottom? Lauren? I crossed them out. What would happen to a 5 on the bottom and a 5 on the top? I cross them out. So what am I left with, guys? K. Do y'all see how that reciprocal made that entire fraction go away? Okay, let's multiply our fractions. What could I do first to make multiplying this even easier, Lauren?
Make the denominator this way.
Okay, so that's only on adding and subtracting. My bottom numbers do not have to match here. Peyton, what do you see?
Simplify it.
We can simplify. What can I obviously simplify here? What could obviously simplify on this problem? Noah? The 6. What did we just do to my 6's here? So what can I do to my 6's here? So now what do I have on the top? 1. What do I have on the bottom? So what's my answer? Let's check it. Let's check it. Remember my original problem says 5 over 6k. 5 over 6k. So I'm still going to have 5 over 6. But what am I multiplying by this time? Instead of k, we're going to use 1 over 5. Right? What could I do to make that simpler before I start multiplying it out? Lauren?
The 5s.
The 5s. Bye-bye, 5s. Because they're top and bottom. Could I do top and top like that? No, they have to be opposites. Opposites. All right, so now what do I get on the top? What do I get on the bottom?
6.
Is that what I had originally?
Yes.
Yeah. Okay. All right, let's look at number 2. Now, number 2 is a little weird. What do you notice is different about number 2?
There's a whole number.
There's a whole number. That's a mixed number. Guys, can I just flip a mixed number? We got to make it improper. So this is where we do that backwards C. So 3 times 1 is?
3.
Plus 2 is?
5.
So I have 5 over 3m equals 15. Did I actually work on solving it yet? No, guys. All I did was I fixed this problem so it's easier. Okay? So now I'm going to start working it. What would I do to this to be able to work it, Lauren? Now I do the reciprocal and flip it and make it 3 over 5. And if I do it to one side, do it to the other. Okay, what happens to my 3's? Cross out. What happens to my 5's? So I have m equals. What can I do to solve that, to work that out? What do I need to do first? Peyton?
You need to make the 15 and fraction.
Make the 15 a fraction. So put it over 1. All right. Do y'all see anything else I could do to make this a little bit easier? Lauren, you said I can simplify, but nothing marks out. What could I simplify? Addison?
5 and 15.
5 and 15. All right, remember for multiplying, we can cross stuff out earlier. So instead of waiting until they're big numbers, I can say 5 will go into 5 how many times? Once. And 5 will go into 15 how many times? 3 times. So now on the top it says 3 times 3, which is? On the top, 9. And on the bottom it says 1 times 1, which is just? 1. Do I need that? No. So my answer is m equals 9. Okay, guys? If I were going to check this problem, instead of starting here, I would go back and look at this part. Why would I go back to that part instead of going to the very beginning?
Because that's a mixed number, you're going to go for
Yeah. You're going to have to make it a mixed number anyways, and we've already done that. So my problem says 5 over 3 times m. What did I find out m was? 9. And we're going to make that 9 over 1 so I can multiply it. Okay. So again, you can simplify. If we can't see what to simplify, I can work it out. 5 times 9 is?
45.
Over? 3. So Kai, would I want to treat that 45 over 3 like a fraction or like division? Division would be the best choice here. So 45 divided by 3, what's that going to give me? 15. And did that work out? Yes. Okay. Are there any questions about these notes? All right. If you'll flip it over on the back. All right. For my first and second period, these are the problems that we wrote out on our own paper. For you guys, I went ahead and wrote them out now that I had time to kind of fix what we were doing today. Again, I'm sorry for my first period. It was not a good day as far as lesson goes, but hopefully this video is helpful. On your homework, guys, it's a lot of multiplying and dividing. But if you'll notice, once you get down to number 8, 9, and 10, I put some adding and subtracting on there for you to go back and practice as well. All right, guys. Go ahead and get started. At the top it says solve and check. Please make sure you do both.